Good morning, guys. Today we're going to be talking about thermochemistry, and specifically energy and heat. So, energy. What is energy? There are many different definitions of energy, and I'm pretty sure you've heard that there's not really one specific definition of energy, but the textbook definition of energy is the ability to do work or produce heat. And chemical systems there are two forms of energy, which are potential energy and kinetic energy, and chemical systems contain both of these, PE and KE. So potential energy of a substance depends on its composition, so the types of atoms, the number and the types of bonds joining the atoms, and also the arrangement of atoms. So those with a stronger bond or a weaker bond, there's a difference in between the potential energy. And the kinetic energy is the energy of motion, and it is also kind of related to temperature. So a repeat you'll see often throughout your 9th grade year is probably the law of conservation of energy. You'll see this in chemistry and physics, and probably in your future too. It's also known as the first law of thermodynamics, and in any chemical reaction or physical process, energy can be converted from one form to another. So for example, a flashlight converting chemical energy to electrical energy. You've probably seen this also in your 8th grade science units, but it is neither created nor destroyed. So you can't create energy, you can't destroy energy. The energy of a system always stays the same. And here's just a little pic of demonstrating the law of conservation of energy with a can shooting. So you might be wondering, why are we talking about energy when the main focus of this video is thermochemistry? Well, that's because heat, whose symbol is Q, is defined as the energy that is in the process of flowing from a warmer object to a cooler object. So I really like this definition because previous definitions of heat, I did not see one similar to this. It did not say that heat was energy that is in the process. It only said, heat flows from a warmer object to a cooler object. And the flow of energy and resulting change in temperature is a clue to how heat can be measured. In the metric system, so a unit of heat is calorie, which is abbreviated as cal, and is the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. Now, there is a reason why I did not capitalize this C, because the capitalized C of calorie is the nutritional calorie, and it is equal to 1,000 calories with a lowercase c. And the calorie with a capital C is the nutritional calorie, or the calories that you see on nutrition labels. And the third unit of heat, the SI unit, or standard, like the standard metric unit of energy and heat, is the joule, which is abbreviated with J. 1 joule is equivalent to 0.239 calories with a lowercase c, and 1 calorie is equal to 4.184 joules. And this is like, you'll be using the calorie with a lowercase c, the calorie with a capital C, and the joule maybe to do some conversions in problems that you'll solve in chemistry. So now we're going to talk about specific heat. Specific heat of any substance is basically the amount of heat required to raise the temperature of 1 gram of that substance by 1 degree Celsius. So if you recall, the water specific heat is 4.184 joules, which is basically 1 calorie, and this means that 4.184 joules must be absorbed by every gram of water. So it depends on the amount of water in grams that is present. That will determine the amount of heat required, and we'll explain this in the next slide with the formula for calculating heat. So different substances have different compositions, and each substance has its own unique specific heat. And this is because since they have different compositions, like the bonding of atoms, it because water has a very strong hydrogen bond, so that's why its specific heat is probably higher than most other materials. If a substance has a higher specific heat, that means that it's harder, it takes more heat to heat 1 gram of that substance by 1 degree Celsius. And finally, this is the formula for calculating heat. Q equals mc times the change in temperature, or T, where Q is the heat. So this is not the specific heat because this is a total amount of heat released or absorbed in a reaction. And mass in grams is M. C is the specific heat. And change in T is the change in temperature. So the change in temperature is basically the temperature of the products minus the temperature of the reactants. If the Q is positive, the substance absorbed the heat. So, for example, an ice cube absorbed the heat from water to melt. If Q is negative, then the substance released heat. So an example of this is probably heat pack. And a better example for if Q is positive is probably a cold pack because it absorbs the heat. And here are just some conversions. A check for understanding. If it was 45 degrees this morning and now it's 63, how do you find the temperature change? So the final temperature is 63 and the initial is 45, and 63 minus 45 is 18 degrees. And here's an example problem of using the specific heat equation. We'll use the equation to solve it. So as you can see, it's a really long problem, and you probably encounter these in your exams and stuff like that in textbook because they give you a lot of unnecessary information. The only information that we need is the information right here. So the temperature of a sample of iron with a mass of 10 grams changed from 50.4 degrees Celsius to 25 degrees Celsius with a release of 114 joules. What is the specific heat of iron? So if we go back to the equation for calculating heat, we need to know, we know the energy, which is 114 joules. So Q, we'll put Q, 114 joules equals, do we know the mass? We do know the mass, that is 10 grams. Do we know the change in temperature? Remember, the change in temperature is the final temperature minus the initial temperature. So this is kind of tricky because we are tempted to subtract 50.4 minus 25 degrees Celsius, but if you notice, it says it changed from 50.4 to 25. So 25 is basically the final temperature, so we will have to subtract the final temperature minus the initial temperature. And this means that it's an exothermic reaction because it releases heat. It has a lower temperature and after the reaction is complete. And finally, our last variable is the specific heat, which we are trying to solve. And we can solve this by dividing 114 divided by 10 grams times 25 minus 50.4. And I'll put that in my calculator. And make sure, a really important thing here is to make sure that you're doing your parentheses right. So use multiple sets of parentheses to make sure that you are doing it the right way. And we get a specific heat of, it's negative 0.448, but specific heat is always positive, so it is technically not a negative. And the reason why specific heat can't be negative is because specific heat is the amount of heat required to raise the temperature. So if you want to raise the temperature, you can't really have negative heat. And citations reference, I used Khan Academy and the chemistry textbook, the 9th grade chemistry textbook for GSMT. It's very helpful. It has a lot of example problems, and I took this example problem from the textbook and a lot of other definitions. And thank you so much for watching. I'll be making future videos on future topics in thermochemistry, and I hope this helped.